scientific method, which at first might seem a little bit intimidating, but when we walk through it, you'll see that it's actually almost a common sense way of looking at the world and making progress in our understanding of the world and feeling good about that progress of our understanding of the world. So let's just use a tangible example here, and we'll walk through what we could consider the steps of the scientific method. And you'll see different steps articulated in different ways, but they all boil down to the same thing. Let's use a tangible example here, and we'll walk through what we could consider the steps of the scientific method. And you'll see different steps articulated in different ways, but they all boil down to the same thing. You observe something about reality, and you say, well, let me try to come up with a through what we could consider the steps of the scientific method. And you'll see different steps articulated in different ways, but they all boil down to the same thing. You observe something about reality, and you say, well, let me try to come up with a reason for why that observation happens, and then you try to test that explanation. It's very important that you come up with explanations that a reason for why that observation happens, and then you try to test that explanation. It's very important that you come up with explanations that you can test, and then you can see if they're true, and then based on whether they're true, you keep iterating. If it's not true, you try to come up with another explanation. If it is true but it doesn't explain everything, well, once again, you try to explain more of it. So as a tangible example, let's say that you live in I don't know, northern Canada or something, and let's say you live near the beach, but there's also a pond near your house, and you notice that the pond tends to freeze over sooner in the winter than the ocean does. It does that faster, and it even does it at higher temperatures than when the ocean seems to freeze over. So you could view that as your observation. So the first step is you're making an observation. Observation. In our particular case, it's that the pond freezes over at higher temperatures than the ocean does, and it freezes over sooner in the winter. Well, the next question that you might want to, or the next step you could view as a scientific method, it doesn't have to be this regimented, but this is a structured way of thinking about it, is, well, ask yourself a question. Ask a question. Why does, so in this particular question, or in this particular scenario, why does the pond tend to freeze over faster and at higher temperatures than the ocean does? Well, you then try to answer that question. And this is a key part of the scientific method, is what you do in this third step, is that you try to create an explanation. But what's key is that it is a testable explanation. So you create a testable explanation. Testable explanation. And this is kind of the core, one of the core pillars of the scientific method. And this testable explanation is called your hypothesis. Your hypothesis. And so in this particular case, a testable explanation could be that, well, the ocean is made up of salt water, and this pond is fresh water, so your testable explanation could be salt water has lower freezing point, lower freezing point, so it takes colder temperatures to freeze it than fresh water. So this right over here, this would be a good hypothesis. It doesn't matter whether the hypothesis is actually true or not. We haven't actually run the experiment, but it's a good one because we can construct an experiment that tests this very well. Now, what would be an example of a bad hypothesis, or something that you couldn't even necessarily consider as part of the scientific method? Well, an example, because we haven't actually run the experiment, but it's a good one because we can construct an experiment that tests this very well. Now, what would be an example of a bad hypothesis, or something that you couldn't even necessarily consider as part of the scientific method? Well, you could say that there is a fairy that blesses, that, let's say, that performs magic on the pond to freeze it faster. And the reason why this isn't so good is that this is not so testable, because it's depending on this fairy, and you don't know how to convince the fairy to try to do it again. You haven't seen the fairy, you haven't observed the fairy, it's not based on any observation, and so this one right over here, this would not be a good hypothesis for the scientific. You haven't seen the fairy, you haven't observed the fairy, it's not based on any observation, and so this one right over here, this would not be a good hypothesis for the scientific method. So we would want to rule that one out. So let's go back to our testable explanation, our hypothesis. Salt water has a lower freezing point than fresh water. Well, the next step would be to make a prediction based on that. And this is the part where we're really designing an experiment. So you could just view all of this as designing, let me do this in a different color, where we want to design an experiment. Design an experiment. And in that experiment, let's say, and let's see, the next two steps I will put as part of this experimental. Whoops, I messed up. I did my undo step. So the next part that I will do is the experiment. And so the first thing is, we'll say there's all sorts of things that are going on outside. The ocean has waves. Maybe there are boats going by that might potentially break up the ice. So I just want to isolate that one variable that I care about, whether something is salt water or not. And I want to control for everything else. So I want to control for whether there's waves or not, or whether there's wind, or any other possible explanation for why the pond freezes over faster. So what I do in a very controlled environment, I take 2 cups. That's 1 cup and 2 cups. And I put water in those cups. Now let's say I start with distilled water, but then this one stays, the first one right over here stays distilled. And distilled means that through evaporation I've taken out all of the impurities of that water. And in the second one, I take that distilled water and I throw a bunch of salt in it. So this one is